So is that okay? Okay.
Question,
Yeah.
I did miss this, but this is 2x minus 5. Why'd you square that?
Why did I multiply by 5 here?
To get x.
Because that's the opposite of divided by 5, so they'll cancel. Where's my x? It's stuck in the radical. I want to kill that radical. What's the opposite of a square root? Square. So if I square both sides, that cancels it. It frees up my variable. Now I'm able to get it by itself. Thankfully, I haven't seen enough homework really.
No need to make checking after we got it. X is equal to.
No, we did. We checked it. I just didn't write down. If you check it,
No, it means we have to make checking.
yeah, you have
Okay.
to.
Okay. Yes.
That'll check.
Okay.
Okay. Thankfully, I haven't seen too many people doing this kind of thing. I used to see this a lot.
No,
What's wrong with that?
no.
Because you have to get rid of the radical first.
Yeah, I can't possibly have the guy break in there. All right?
You have to square it also.
We don't have the right tools for that. Yeah, you got to square it.
Yes.
You do one thing, you do two.
So it's 2x minus.
True, but you can't add 5 because you can't break in there. You got to square it, and now you basically took the whole damn building down.
Yeah.
And now you can get at the pieces inside.
49.
Ah, thank you. Right?
Checking and.
Okay. So really, when you're doing a problem like this, and we had a lot of trouble with this on that quiz. When you're doing a problem like this here, this is not the same one as on the quiz. It's kind of close to one of them, but it's really almost the same thing. It's just that they're not all being divided by the same thing, are they?
LCD.
Yeah, so I need an LCD here, right? So I have a few people that just say this, and say x is 1. Yay! How the hell did they get there? How did you get from here to there? There's nothing you can do to get there. Nothing, right? So really, to me, the best way to keep this straight, and it's not the only way to do this, but to me it keeps me straight, is give whoever's missing what they're missing.
Right,
Before I can do that, I got to know what everybody's got.
really.
And what does this guy have here,
X minus 2, X plus 2. Yeah.
right?
That
So
one
just
has-
rewrite it. So now I can see who's missing what. What's he missing?
X minus 2.
So multiply top and bottom by x minus 2.
Yeah.
Right.
What's the last guy missing?
X plus 2.
X plus 2. Multiply the top and bottom by x plus 2. Now, I sometimes have somebody say, well, why are you allowed to do different things to both sides? I actually haven't done a damn thing to either side. I haven't done anything. Because what is x minus 2 over x minus 2?
1.
1. I multiplied by 1, essentially. I've made it look different, haven't I? But it's still the same thing. I just need to make it look like this guy. Now, when I get those like denominators, what can I do then? Let me write down what we have here.
X minus 2.
I'm going to be a little more blown out here than normal.
2x plus 4.
Now that we have them all the same denominator, what am I allowed to do since this is an equation?
You could combine.
Combine
like
We have to
all
combine
together.
the.
I could combine like terms. You're right.
Disregard the
But a
bottom.
more direct way to do
But
this.
it's x minus
Oh,
2.
Why are these stuck? Why are these stuck? Because they're being divided by, they're all being divided by the same thing, aren't they?
So this cancels everything.
So let me multiply everybody by this.
X minus 2, X plus 2.
Let me save some time. Is that right? It's next to everybody. So this will cancel with this,
Yeah.
this, and this.
Okay.
If you make them all have the same denominator in an equation, I'm allowed to multiply both sides by anything I want to, and then multiply by the thing that's going to kill the bottoms. Now I've got a beautiful little equation, right? Who's left alive here?
X minus 2 plus x.
Good?
Is equal to x plus 4.
Yeah, and then you can bring that through. Now I made one, of course, that has no solution, but that happens sometimes, I think. So you get 2x minus 2 equals 2x plus 4. You get negative 2 equals 4, right? Subtracting 2x. What does that mean? What does that mean?
And no solution.
No solution. Yeah, that's never true. So this can never be true. That won't happen too often, but I just happened to make one up that had no solution. Oh. We know what that means though when we get to there. That means there's nothing x can be to save this. Negative 2 can't be 4, so there's no solution. No x can save it. Yeah.
If we have x squared minus 10x is equal to 2.
So that's kind of like the last thing I did. That was the last thing I did last time, was the completing the square.
Yeah.
Is that on the...
Yeah.
Oh, yeah.
7A.
7 and 8, like I said, aren't going to be on the test. They are on the answer key. I went ahead and did the answers since they were on the practice test. Right? And we'll get back into that next time, I think, at the moment. I'll give you the answer key, but let me see if you guys remember what's got to go there
Well, you get half of it.
to complete the square.
16.
16 of course. What's half of 8?
4.
It's 4. And what's 4 squared? 16. Those are the 2 steps you need. And that was just because we noticed the pattern. We noticed that, what do you get when you do this? You'll get x squared plus 8 is plus 16 is equal? Plus 64. Sure enough, 16 is twice 8, right? And 64 is 8 squared. Don't worry, it's not the same as that, it's just an example. And if I do x minus 5 squared, what will I get? I get x squared minus 10x plus 25. Again, half of this is there, right? Half of this is that number. That number squared is that number. We notice the pattern, and it shouldn't be that big of a deal, is it? Of course, this is twice 8 because you get 2 8s. Of course, this is twice negative 5 because I get 2 negative 5s, right? Negative 5x and another negative 5x. So it's not an amazing thing. We just said, well, that's a cool little pattern. Now I know that there has to be a 64 here for this to work. And I know there has got to be a 25 there because 5 times 5 is 25 for this to work. Half of 10 is 5, 5 squared is 25. Half of 16 is 8, 8 squared is 64. Half of 8 is 4, 4 squared is
16.
So that's what's got to go here to make this work. So we'll pick that up again. I just want to remind you, that's what we, a little tiny bit we did last time. It's not going to be on this next test, but that's the first part of chapter 8.
Chapter 8?
Yeah.
81, I see it
Okay. Cool. It's really just noticing a pattern. It's just noticing what number has to go there so that it can factor like that. And anytime you have something like this, something squared like this, the middle's going to be twice this guy. And the last one's got to be this guy squared. It's very straightforward. Now we're just going to do it backwards. Now I see the pattern, now I can apply it somewhere that I don't know what number is there. I can see what number is supposed to be there.
Also this one, x plus 8 to the square 2. Make it by half and then you make it square?
Yes. Well, now if I had this,
Yeah,
and I want to know what has to go there.
yeah.
What's half of 12?
6.
36.
So negative 6. And then what's negative 6 squared?
36.
So it's got to be 36 here. And then won't this factor like x minus 6 squared? Negative 6 is negative 12. Negative 6 times negative 6 is 36. So it's just using a pattern, which is math, what math is really big on, obviously, is using patterns. But again, let's say that. Okay. Let's see. Oh, I was kind of building up to your question before, and I never got back to your question. What do you think you do here?
Okay, first, would you, to get rid of the radical, would you
Okay.
square it?
Sure. Right, the radical's by itself. The radical piece has been isolated. So to kill that radical, I can square both sides. Right, they're opposites of each other. So if I do one to the other one, they cancel. Wow.
Magic music.
Now, of course, the other side is gonna be ugly. I did my side, so I did my half of the work. Square the square root, it cancels. The biggest mistake I see is people trying to foil this thing. Why would you? The square died. The square root and the square had to kill each other. They canceled, so it's just this. Don't square this also. You don't have two squares up there, you just have one that died. Now the other side's gonna be
And then you foil.
kinda ugly.
Yeah.
One thing you can do to make it a little better,
Is multiplied by 30.
14.
multiply actually by what now? Be careful. You have that squared over 3 squared, which is 9. You can multiply by 9. I like it, right?
Yes.
You just attack the bad boy. You know how to square fractions. You square the top, you square the bottom.
Yes.
I don't like that 9 where he is. 9, he's all right, but I don't like where he is. So like Eli said, you multiply by 9 to make it look a little better. And then you have to foil this bad boy out here, right?
Yeah.
You guys keep going with that. Let's see what you get. Foil that other side out. Let me see who knows what to do after that.
So you can do it.
Okay. So what you guys are good? 4x squared minus 20x plus 49? What do you do after that? What part of this problem tells you what to do next?
Then
Combine.
you move those to the other side.
Okay, cool. So set it to 0 by moving stuff over, and then you combine like terms. So if we put all that together, that's cool. That's the next step. What part of this problem tells me I need to get it equal to 0? The square. I love it. I can't get x by itself. I can't do it like chapter 2. I need some other procedure. So sure enough, if I get it equal to 0, I can factor that side and set each piece equal to 0, right? So let's see, subtract that. Get some ugly. How's that? What's one thing you can do, because to make this a little bit better on yourself,
4 by 22, 88.
before you do that, what's something you can make? Yeah, you can divide everything by 2, right? Now you can do the 2 times 11 thing, right?
Either way you can do it, right?
Either way you can do it, but it's nice if the numbers are smaller.
Wait,
You don't have to do that, just makes it
Yeah.
easier.
oh, so do you divide by 2 or out? Is that same?
Either way,
The
either way.
of
If you
both
pull a 2 out, it gets a little misleading at the end. I mean, we're trying to get to the point where we have, real quick, a little side note. If I had this, Can somebody tell me what the two answers are?
Positive 1 and a negative 4.
Beautiful, because positive 1 makes that 0, and negative 4 makes that 0, and if either one of those is 0, the whole damn thing is 0. That's the idea. Either one of those x's makes the whole thing 0, because it makes their pieces 0. Now, here's where people get thrown off. That has the exact same answer. 2 is not suddenly an answer, because this would say, okay, if 2 equals 0, okay, that never happens. So I'd much rather just divide by my numbers to get them the hell out of the way in the first place, so they don't mess me up later. Numbers you can divide by. You cannot divide by variables, because the variable, it could be 0, right? So here, if you want to, you can do this is not too bad. What factors of 22 add to be 23? It's got to be.
What does 11 do?
They don't make 23. 22 and 1. Yeah. Whenever the middle guy is 1 off from that guy, it's got to be that guy in 1. Of course, they're both negative here. And this is the part that I understand that a lot of you guys are not interested in mathematics. I understand that a lot of you guys don't see the use, which obviously kills me a little bit inside every time I hear that. Because there's stupid amounts of uses for these things. You could not have one of your little smartphones without math. But you've got to develop stamina, right? I mean, this problem, I understand you guys call this a long problem. It isn't. But it is long because there's more than 4 steps. But each step by itself, you know how to do. A lot of you guys either get the steps jumbled. You start looking back here. I don't care what's over here anymore because I'm there. So cover this. Or you just get to this point you're like, okay, that's enough problem. But you got to have stamina. This is not a hard problem, right? What comes out of these two?
You group it too.
2.
2x.
Yes, that's right.
Yeah,
11.
x minus 11.
Now what's got to come out of there to make it the same?
Yeah,
A negative 1, right?
Yeah.
Because these signs are wrong, and now the signs are correct. I still have people getting like a plus there, and somehow they do the next step. The next step can only be done when this is the same as that.
Okay, but now you're going to be about 2x minus 1 and
I like
x
it.
minus 11.
I like it?
So, does the 2 throw us off at all?
No, not at all. Because what's got to happen to make this true? Either this has got to be equal to 0, solve,
And then you do
or
that too.
this has got to be equal to 0, solve. Right? You'll get a fractional answer, I don't care, because I'm done. And when you solve this, you'll go to x equals 1/2, or x is 11. Now what do you have to do at the very end, considering how this problem started?
Put it back in.
Yeah, every single radical problem you must check.
Yeah.
We have to check after that.
Yes. When you plug a 1/2 in,
1 plus
you have
3
to
is
check to see if it
4.
works out. I think that one won't work, but the 11 will. Yeah.
Would there be negative, x equals to negative 1/2?
No, because you'll add the 1. So the 1 becomes positive.
Okay, cool.
Yeah. Actually solve it. Don't try to think. Just solve that little tiny equation.
That's your question? When you plug it in, where it's the 2x plus 3 and the 2x minus 7, do you?
Yeah, so to check this, and now I'm going to lose a few more people, especially people that thought this was long enough here. But to check this, you would put back in a 1/2.
That's what I thought.
Right? You got to go way back to the beginning. The answer, it might work here, but that's after you came in and squared. You got to check in the very beginning. They might not both work in the very beginning. By squaring, I changed the problem. I actually made this number become positive now, didn't I? If I square this, it's now positive because we're assuming it's not complex. So here I get square root of 1 plus 3, square root of 4 is 2. Over here I get 1 minus 7 over 3, negative 6 over 3, negative 2. No.
Yeah.
And 11 should work, yeah. So do the same thing with 11, plug the 11 back in, and I think it should work. Okay, cool, yeah.
Yeah, actually, that is right.
Phase,
Fifteen under three, it's fine. Yeah, that checks.
Oh, okay, oh, that was the one I was doing, basically, it's like number 23, this one I think was number 23. 27 is the same exact way. Yeah.
is, 2x squared
You know, she knocks it
minus
out.
23x minus 7, but I can find, the final.
Let's see now, let's see, wait, let me catch up to you, 63x plus 18, right. I think you just, I mean, the minute one of your numbers is off a little bit, it's gonna throw the factoring way the hell off, right? So you should get, if I look at this correctly, 63x plus 18 equals 4x squared plus 8x plus 4. Did you get that at some point?
Which number?
Oh, yes.
Yeah,
I
so,
know.
so it should be okay,
Yeah.
4x squared minus 55x minus 14, right? Yuck.
Yeah, yeah,
And then it's 4 times 14. Oh yeah, so it'll be 56, it'll work. Yeah, it'll work. Sorry guys, that's number 27, which is exactly like this one basically. Same exact steps. Get a slightly more disgusting thing to factor, but it's the same idea. You just pound away that bad boy and get it to factor.
Number 55. Phase, 585.
585? Oh, okay, cool. I like this. So 55, it says, you have an equilateral triangle. Yeah, page 585, it's
585.
section 74. So equilateral triangle, is that equilateral? Who knows what equilateral means? Equa, equal. What's your lats? Where are your lats? Who works out in here? Where are your lats? Careful. Well, you would know, but aren't the lats on the sides, right? So lateral means sides.
Oh, yeah.
So don't they have equal sides? 2x, 2x, and 2x altogether? And then what it's asking you now is, what is it asking you? Find a ratio of the height to one of the sides.
Yeah.
That's what it's asking for, right? So what I'm missing then is the height. Now they give you a major hint, because they did all, this is the picture they give you. I'm missing this. And don't I have here, what kind of triangle?
Right triangle.
Yeah, right here's a right triangle, right? This is a right triangle, cool? And what do you know about the sides of a right triangle?
I think you will have to put the,
Yeah, so let's call this my h, let's call that one my height. So what's gotta be true then? X squared plus
plus h squared.
h squared equals
2x squared.
2x squared. Now you can solve for h.
Yeah.
Cool.
This is written x squared plus x squared written in the.
Why is it, why is it x squared plus h squared equal to 2x squared instead of x squared plus 2x squared?
Because you already have a
Which side in
hypotenuse.
the right triangle is always the longest?
The hypotenuse is
Yeah, the one
2x.
across from the biggest angle will be the biggest side. So doesn't that mean that the other two have to equal it?
Yeah.
So you never have a question about what side the hypotenuse goes on. Here, these don't matter. I don't care which one you call which. I'm adding, so who cares? But the hypotenuse has got to be the guy that's by himself. He's made of the other two sides. That's why he's the biggest freaking side. Right? So all I did was good old Pythagorean theorem. I'm not trying to make it sound like this is an easy problem. It's weird because I know as a student you want a number answer. You're not going to get it because we don't know what x is. You're going to get an expression with x. But it's applying Pythagorean theorem to find this height.
Yes.
I got a nice little right triangle. Now you get the h by itself, right?
X squared over.
X squared.
Yeah, I can subtract the x squared. Now what I have here, what's this though?
4x squared.
4x squared minus x squared?
3.
3x squared, right?
Yeah.
And then how do we get h by itself?
Root of it.
Square root.
Uh-huh.
So we get h equals, what can I do the square root of here?
X.
Square.
I'll
X.
Square root of x squared is x? What's
No,
the
no.
square root of 3?
X.
3,
I don't know.
radical. Yeah.
So now the height is x radical 3. And they say find the ratio of the height to a side, right? What would that ratio look like? The height
Yeah.
to the side. So it'd be x radical 3 over 2x. I hate that question.
Huh? What
This is math. Math can be on the test.
X could be,
So what can you do there?
yeah.
So again, let me go back, and again, this is not an easy problem. If this is the only problem you had trouble with in this section, you're gonna be fine. I love it. You're fine. This problem is for the people that can go a step further. It's a challenge, the people that can go a step further. It's just the right triangle. I know the side, these two sides, and I don't know the height. So call that h, because I don't know what the hell it is. The minute I do that, what can I set up? Because it's a right triangle. Pythagorean theorem, right? This side squared plus this side squared has to be this side squared because it's a right triangle. It's true for all right triangles, right? Solve for h. This is why it's in this section, because I take a square root. It's got radicals in that bad boy, right?
So now can you cancel the X?
Yes, cool. Now it says take the ratio of the height to a side. So put the height on the top, one of the sides on the bottom,
So then you get
Like you said.
radical 3/2.
radical 3 over 2. And that's true for any equilateral triangle. The height divided by side will always be radical 3 over 2. And again, I really want to emphasize this. I give you problems, especially in that section, applying the concepts that go a step beyond the regular nuts and bolts. If that's the only place you're having trouble in the homework, awesome. If it isn't, forget about it. Work on the nuts and bolts stuff. Much more important that you know how to do something directly than how to interpret a given situation. I mean, this is a multi-step kind of problem. You got to feel comfortable working with a few different variables. Not all of us are. So, okay. So any other questions from the homework? If you're not sure what the hell to do right now, you can do the practice test or quiz corrections. Yeah, Laura.
Can you number 40 and 74?
40?
What do we need to be up to in homework by Wednesday?
End of chapter 7. 7-7. I try to give you some problems like this that's got functions in them every now and again. And they're really the same as the earlier problems. You got two pieces. If I just call one of them F and one of them G and then I say add them, I just got to put them in there and add them. G of X is this here. And then it says find, it's trying to be a 3. Find F plus G. This is really just substitution now. What is F of X?
X plus root.
X plus radical 3. Plus, what's G of X?
X plus 2 radical 3.
And now you just combine like terms. What are you allowed to combine here? The X's. Oops. 2X.
Plus radical 3.
Careful.
3 radical.
Plus 2.
Plus 2.
3 radical.
Yeah.
I got a radical 3 here. I got 2 more of them there. So how many radical 3's do I have?
3.
3. Right? Don't forget that now. It's just like terms.
There's a 1.
I lost you.
So there's one radical.
If I have 1 radical 3
Okay,
plus 2 radical 3's,
that's 3.
that's 3 radical 3's.
Yes.
Right?
Yep.
So remember, so that's done. Little side note. Square root of 5 plus 7 square root of 5. That's exactly like I don't know what plus 7 of those I don't know what's.
8 squared root.
They're really the same
Radical
thing.
5, yeah.
Exactly. X plus 7x is 8x. One thing I don't know plus 7 things I don't know is 8 things I don't know.
Right.
So 1 radical 5 plus 7 radical 5s is 8 radical 5s. They work the same way. I'm collecting all these pieces that I don't know. I'm just putting them together.
We just want to put the 1 out there.
Yeah, there's an understood one always there, right?
Yes.
There's nobody else out there. Okay. Let's see. I was a lot of people just had trouble factoring. So of course that quiz is going to kill you, because if you can't factor, you can't do the true chapter 6 steps. Factoring is chapter 5. Once you factor, you can cancel whatever's on the top and the bottom. One thing I really hated to see was something like this here. I understand why you want this to be true, but am I allowed to do this?
No.
No, LCD.
Several things wrong. They're both on the bottom,
Right.
and the operation is addition.
Yeah, but with the other-
Even if this operation was multiplication, would they cancel?
No.
Because one's not on the top, the other one's on the bottom. They're both on the bottom, so there's no way those could cancel. No way.
The only way you could cancel if it was on top and on the bottom, correct?
Sure.
On the same.
On the same thing, then I can cancel them out. What's the right way to do this kind of problem, of course?
Factor the whole thing, across the whole.
Well, everything's been factored already, right?
So what you don't have to give
Then
the
you
other
find
one
what they
doesn't
need.
have.
Yeah, what is he missing that he's got?
X
Just
minus
X
3.
What truly tells me to do that? What tells me to do that is nothing other than this is a fraction trying to add another fraction.
You have,
I've known since Math 80 that I need like denominators to be able to add them together. I know there's a whole new dimension with the variable. What I'm trying to get you to understand is that variable does not change the property. I can't change ideas in math. I don't care if I stick variables in there. It still needs a like denominator. I don't care. It's a fraction. It needs like denominators. So this guy's missing
X minus
x minus 3.
3.
Yes.
And now I'm able to go ahead and put them together
Yeah.
And then you're gonna
over that
cancel-
like
then you
denominator.
can cancel out.
Now be careful
X
then.
minus 1.
What was it?
Yes.
Why can't I cancel these out?
Oh, because you got that.
Plus.
Division does not
Add the-
cancel addition.
Right.
Yeah.
I understand, again, trust me, I understand it's human to go, well, I can get rid of a big chunk of this ugly thing, and we desperately want to do that,
Okay.
but you're not allowed, you can't, division can't cancel addition, so you can't do that.
Okay.
And it's the same thing as before, can you reduce 5/8?
No.
Even though 8 is 3 plus 5?
Yeah, but no.
Whee! No, that doesn't make any sense, you can't do that. Again, division cannot cancel addition. Okay, cool.
Are you gonna go over any of the practice tests?
Sure, yeah, it's up to you guys. Um,
2D?
2D? Okay, good. That's one of those ugliest radical problems. Somebody remind me again, how do we handle, how would we handle something like this maybe, by itself? How do I handle numbers inside radicals? What can I try to do with them?
With 3
Break it down.
Yeah.
In this case, what makes sense? 6 and 4 don't make sense.
8 to
8
3.
to 3.
Why does 8 and 3 make sense?
Because 8 is 2.
Because the cube root of 8 is
2.
2. So I was going to break it down into a piece I can do and the extra, right?
Yeah.
So this is 2, and I still have a 3 radical 3 I can't do anything with. How do I deal with the letters? So like, what would the 5th root of w to the 7th power be? How do I do that?
Oh, you take the W out and leave 2 in there.
W outside.
5 goes into 7
Yeah.
And then do 2 radical.
At one
once with
W2.
2 left over. I love it. Or if you want to, you could break this up into W5, W2. 5th root of W5 is W, 5th root of W2, I don't know. Either way you do it, you get the same answer, right?
Uh-huh.
Cool. And again, another thing is, what does a fifth root look for? Groups of
5.
5. I've got one group of 5 W's and an extra 2 W's. So one W comes out for 5 of them, and the extra 2 are still in there. All right, so there's 3 kind of different ways that are all actually the same. So that's why on this problem, I've got to attack the number, because it has a way to do it. And then I attack the letters, because they have a way to do it. And why do they have 2 different ways to do it? Because these are factored. I got 14 B's multiplying, don't I? Is this factored? No. So if you did factor this, you could actually attack it the same way. But what's a better way to do it? What piece of 320 can I take a fifth root of? Who might know?
Yes.
Has this number showed up enough? Or you can start to break it down,
Yeah.
right? But maybe you should know some 2 squared is 4, 2 cubed is 8, 2 to the 4th power is 16, 2 to the 5th power is, hey, right? So that 32 should kind of stick out in my fifth root. I can't make it something crazy. It's probably going to be 5 2s. So what can I break 320 down as?
32 by 10.
You get 2
32 times 10, 11.
Yeah.
All right? What's the fifth root of 32? 2.
Yeah.
Because it takes 5 2s to make 32, right? So fifth root of 32 is 2.
2.
I still have a 10 in there, right?
Yeah, 10, yeah.
A lot of times people take out the wrong thing.
8 outside.
Good. 5 goes into 6.
Whoa, wait.
Wait.
The 2. What was your explanation for the?
What's the fifth root of 32?
2. That's where it goes outside.
So again, the mistake people make is they actually, and it's not wrong to say this, but technically it is. I'm not taking something out. I'm doing what the problem says to do. What is the fifth root of 32? It's 2. So I'm not taking something out, really. Because that's where people start to take the 10 out somehow, and that's neat. I'm doing the fifth root of 30. Now, why is the 10 still in there? Because what's the fifth root of 10? I don't know. Something ugly. All right, so keep it in there. 5 goes into 6.
Yeah, 1.
Once with
A1.
1 left.
Yeah.
5 goes into 14.
B2.
Twice with
B4.
4 left. 5 goes into 4.
C4.
None.
None.
C stays there.
C4.
So no C's can come out because there aren't enough of them. The fifth root needs at least 5 things. I've only got 4 C's, so of course it makes sense I can't do anything with the C's. There are not enough of them, right? There are too many B's. How many too many? 4 of them, right? That's why there's 4 left over at the end. Okay. Yeah.
Thinking about, you know how you get rid of a square root, but you don't have a number in there like that? You know, you have to use like the fifth, you can square it by 5 and
You can raise it to the 5th power. Exactly. So what you're saying is if I had an equation with a 5 in there,
Right.
what could you do to both sides?
You raise it to the fifth power.
Raise it to the right power, the 5th power in this case. Raise it to a second power can't kill a 5th root. A 5th power kills a 5th root. You better do the same thing on the other side, right?
Yeah.
Raise both sides to 5th power so you free up your variable. Why do I square ones with just radicals on them? Because that's the second root. It's a square root. The opposite of squaring. If it was a cube root, I would cube. 8th root, I would 8th power it.
So we get the root right there. We still don't change nothing inside of the cube.
Yeah, these die.
Yeah.
So you're just left with what's on the inside.
Yeah.
You kind of like free it up.
33.
And now you can just add the 1.
X 33.
Cool. Yeah. Oh, wait. Yeah.
Got lost on the B4.
5 goes into 14 twice with
4
4
left.
left over. Oh.
Okay.
So as long as you can say that, you're perfect. When you say left over, you mean left over. They weren't able to be done, so they're stuck inside still.
Please, 2C.
Oh, yeah.
The second example is if it is W minus 7, it will be minus root
Yeah, well, if it's -7, the
Yes.
first thing I would do,
negative
if it was
here.
-7, the first thing I would do is to do this.
Yes.
And then it's 1 over fifth root of W7.
Oh, okay.
And then that's going to say, now it's 1 over.
Yeah.
And then if I needed to, I could
Yes.
rationalize this,
Yes.
right?
As you do.
So if it's a negative power, I would first flip it so I can attack it directly. What's the fifth root of 1? 1, because it takes, what's the 87th root of 1? 1, right?
Yeah.
Did you do 3F?
I'm doing 2C right now.
11.
Now I would take, there's two answers I would take on this.
Yes.
I don't say use complex numbers, so what's one way to answer this? Not real. Because I'm trying to do an even root of a negative. Now I would accept the complex answer. Remember how you can do this? You can do, split that up.
Yeah.
What's the square root of negative 1?
I.
I. Square root of 16? 4. So you can say it's negative 4i. Right? Sure. So either way, if you say not real, I love it. That's fine. I didn't say use complex numbers. If you say negative 4a, I love it because that's what it is.
We can't say not real, or we can't say not minus 1.
Because now we know complex numbers.
Yeah.
Later, I'm very specific on number 6 to say simplify using complex numbers. Then I must see you do this. Earlier, you could say not real, that's fine. But when I say use complex numbers, you better tell me the complex answer. Right?
If it is the square root, it's not square root, a third. 3. No.
Yeah, we're not going to do, well, in this case, it'd be, I thought, if you say fourth power, that gets rough. But a cube root of negative 16,
Yeah.
I could do that directly.
Okay.
Which roots have problems with negatives?
The even number.
Even number roots,
Even,
right?
yeah.
Square roots, fourth roots,
Yeah.
right? Because if I have 4 of the same number, it will always multiply be positive unless it's imaginary.
Okay.
Odd roots are cool with negatives. How would I split 16 up so I can do the cube root of it?
8.
8.2.
Yeah, negative 8 times 2.
Yeah.
Cube root of negative 8 is
Minus
2.
2.
negative 2. And cube root of 2, I don't know.
Yeah.
So odd roots are perfectly fine with negatives. Because when I cube something negative, isn't it still negative? 2 negatives make a positive, there's an extra negative left over. Right? Negative 2 times itself 3 times is negative 8. But if I square negative 2, it's positive 4. That's why a square root can't handle negatives, but a cube root can. So let's do this. Let's do an example here of each type of problem you're going to see. Let's bring this back and make this a little more organized. Let me ask you before I forget. I'll give you guys the answer key.
Yeah.
Mike, you want to answer? Okay. I'm guessing you do, but you have to do it. Oh, I love my purchase.
Also, I'm saying,
By the way, after this next test, I'm gonna give you an updated grade sheet like before. And now it's gonna say what you'll need to make on the final to pass, to make a B, to make an A.
Okay,
So you'll know exactly what your target is.
so we can correct this and give it to you.
Yeah, sure. You got it?
No, no, you did.
Oh, but yes, you can. Yes. Yeah.
تدقيق صفحي
Number
وتجديد
51, 578. Got a question about that,
بعد
radical,
Wait. 51 on,
578.
oh, 578. I thought you said, I heard you say 57, I didn't mean section 57.
Oh, no.
Page 578.
Section 73. 51.
Yeah.
Alright. We'll do this real quick and then I'll start doing, we'll do an example of each type.
You're missing 3E and F.
Yeah.
Oh, no. My eyes wandered as I was doing it, so if you look at number 2, at the bottom of the first page, I did D, E, and F for the next problem. Yeah.
Thank you.
My eyes just kind of went in the wrong place. I said, oh crap, there it is.
ADD kicking in.
Something like that. The instructions here say rationalize the denominator, right? And why can't I not just go ahead and do the cube root of 9?
Because that's the square root.
Yeah, I could do the square root because 9 is made up of 2 3s. So what's it missing to be able to do a cube root of it? Another 3. And I really like to teach it like this for 2 reasons. 1, it's very simple, and 2, it's the thing we do. I'm not making it any simpler than it's supposed to be. I'm not cutting corners. This is what we do. Aren't there several problems where we give the people what they're missing? Or they got that, let me give them that. Same idea here. If only there were one more 3. So give it to them. If I multiply the bottom, and I can't just multiply by 3, can I?
No.
Because it needs the same roots.
Yeah.
So I got to multiply by that missing cube root of 3. If I do something to the bottom, I better do it to the top. That's why I like calling rationalizing denominator, I like calling it completing the root. If the root is 3, make sure you got 3 of everything on the inside.
This is completing the root.
That's what I call it. I don't think anybody else calls it that, but it just makes more sense to me to call it that. You can see why they call it rationalization though, because the next step, what do you get on the top? Good, you can't put them together. Don't tell me 6, because you can't put the 2 inside. What do you get on the bottom?
3.
Good, because you get the cube root of 27, which is 3. Now can somebody tell me, cube root of 3 by itself, what kind of number is that? Is it a whole number? Is it integer? What kind of number is a cube root of 3? Irrational, I love it. It's an irrational number, right?
Yeah.
Rational numbers are the ones that you can make look like fractions. All whole numbers are rational because you can make 2 over 1. So the bottom, it used to be irrational, didn't it?
Yeah.
What's on the bottom now? Which is a rational number. That's why they call it rationalizing the denominator. We're making the bottom rational. Because it sucks that there's a freaking fraction in the first place. It sucks even more if it's got a radical there. So we say, we can at least take care of one of those things. Let's not divide by a radical. Let's put that up top. Let's make the bottom a nice whole number. Nice rational number. That's why they call it that.
So if that problem had been
A 4.
instead of a 2 on the top, if it had been a 3, could you?
Same answer. I couldn't, yeah, you could cancel the 3, definitely. Right? Independent of what mess you're doing, at the very end, if you got something you can cancel, hell yeah. You can cancel. I don't care what it came from. You just look at what you got at the end, cancel what you can. Here, I can't cancel anything. Alright, so let's talk about the type of problem you're going to see. I'm obviously going to give you, well, basically everything on the day practice test, but I want you to understand what each piece requires. Right? So I'm going to give you several problems where you have to add and subtract rational expressions, right? Like number 1a, number 1b, 1c, those type. And just remember what it is that you need to be able to do that. You need like denominators, like we've needed forever, right? You just factor what you can, give people what they're missing.
Please, number 8.
We'll get there. And then you're going to see several problems that are going to ask you to multiply or divide, like 1d, 1e. The problem on the quiz, a lot of people were able to do 1c on the quiz, but then they left 1d blank. I don't know if it's because the specific factoring I put in there was bad, or if you just looked and said that's too big of a problem for me to worry about, but 1c and 1d are the same. 1d just has more stuff in it. It's still the same. I factor and kill, factor and kill. And what saves your ass on 1d, what saves your ass in general on factoring is what do you always try first? When you factor, what do you try first? GCF. Because sometimes it's the only thing you can do. Right? Okay.
I have a question in your answer for 3C. On your cheat sheet, you've got 3 A's and 3 4's. Would you take the fourth one?
Wait a minute, 3C.
The square root of 4 is 2, right?
Yes, square root of 4 is 2. But what root do you have?
The third. So
Okay, there you go.
you go 1.
Square root of 4 is 2. Cube root of 4 is something other.
You're only going out, when at 332, you're only going to the third square root. The third root.
You have to do the root that's there.
Okay.
Like here, I can do the square root of 9, but that's not what it says. I think we're a lot more used to the radical symbol by itself than we are with the numbers that go in it. And the problem is the fact that they decided to just have a radical by itself, meaning there was a 2 there. If they would have said instead, I know we can save some time, but it'd be easier for students if we got them used to this, I think that would have been better. So a lot of people think that the radical is by itself and that 3 is some extra symbol. No, this is a cube root symbol. One symbol. That's a cube root symbol, not a 3 square root of. I always hear people say that kind of thing. They say, third square root of. No, no, no. Take the square word out of there. Right? It's not a square root. There's a 3 there.
Cube root.
It's a cube root. I love it.
The last one, 8, please. If you have time.
Yeah. Real quick. Obviously, if you can't factor well enough, problems like number 1 are going to kill you. Right?
Yeah.
You got to be able to factor it, and you just got to realize, just cover up the other parts of the problem and work on one piece of it at a time. Factor, and then kill. 2 we've done some examples of. I think 3 should be relatively easy, is what I'm hoping. I don't know, we'll see. 4 is just like 3, right? When I want to try to combine anything, I have to have like terms. So like on 4b, I've got to first try to simplify those to have them all the same number in the root, right? So that I can put them together. 5, we've talked about, you got to kill the radical. 5c, I'm not going to really have a problem like that probably. I just want to do the more nuts and bolts problem. 5c is a little more involved. You got to do something twice. 6 with complex number. I had a question on 8. Let's do some specific questions then. 8's not going to be on there. We just haven't gotten there yet.
So we can leave it?
Yeah, in fact, I should have used a quadratic formula. Who knows the quadratic formula? What is that quadratic formula?
Negative b, negative plus under the radical of b squared. And then what is it, 4ac, and then 2a.
2a.
Does that sound familiar?
No.
If
Now
not,
it sounds
we're
familiar.
going to be talking about it a week from today. And I'll show you where it comes from. If it does sound familiar, awesome. This comes from somebody actually solving that equation. I mean that equation. They solved it with all the A's and B's and C's in it, which we'll actually do on Monday too. It's not very difficult. Right, we can go, good job, but it wasn't that hard. Don't get all excited for solving it. It's not really that difficult. It looks disgusting. I know. The nice thing though is if I have anything like let's talk about 8 a little bit. In 8, what's A, what's B, what's C?
2x
2.
squared.
No,
Careful.
just the 2.
What's A?
Is 2.
2. Right? A x squared. So what's A? It's got to be 2.
Okay.
What's B?
4, negative 4.
Negative 4. And what's C?
3.
3. The minute you can identify those, can't you just plug them in there and get the answers? Plug those numbers in, work it out, get what x is. Right? If I solve it with all the variables in it, then I just got to plug the variables in, and it's already solved. X is already by itself, I just got to plug the right numbers in. That's the idea of the quadratic formula. It's a shortcut.
So it's kind of like you can either do it as a complete the square, the quadratic formula, it will give you the same answer,
Quadratic
right?
formula is a shortcut for
Is it?
completing the square.
Yeah, because I haven't really worked on it, but like you said, it's not that difficult. I
No.
kind of did the homework already.
Quadratic
So it's simple.
formula is a shortcut to that thing we were doing earlier about taking half and squaring to figure out what number has to go there. Yeah.
And you will give us this formula?
On the final, yes. On this test, this won't be on it. Again,
it will be
number 7 and 8 will not be on this next
Ah,
test.
okay, 7 and 8.
So
No.
I think one of the is still.
It's gonna be all radicals.
Number 8,
No, 1B.
1B. It's entirely possible.
Must be minus 7,
It's-
7A
So
minus
7,
B.
8's not in our test.
No, because then negative there, we'll go through and change the
But
signs.
you will explain it to
Yes.
us again?
Later,
This is
after
my
the
mistake every time.
No, not every time.
It will probably be on the
You
final.
pointed me
In
out.
the
so-
final.
In the final.
It means you will explain to us after
Okay.
the test.
And guys,
You ask him.
I got a workshop to set up this week, and there's gonna be 2 final exam review workshops next week. I should be sending an email about all that later today. Okay, so I think the one this week is gonna be this Wednesday, 11 to 1. So look in your emails for that. It's gonna be a workshop specifically about radicals.
I never get emails.
What's
Do you
up?
have my right email?
If you have the correct email in WebAdvisor, then yes, I've got your right email.
You say Wednesday, 11 to 5, 11 to 1?
11 to 1.
A1.
No 6 hour
And that's gonna be
workshops.
like a kind of like a review thing? or-
Yes.
Okay.
It won't be me leading, it'll be a gentleman named Dan Greenhead. If you guys know Dan. He's very gung ho about these things, so.
In the math center?
I'll tell you the room. I gotta find a room.
Homework is due.
Oh, oh, Karen. Did you get your?
The ones I got confused on, those are the ones I got on my computer.
Oh, yeah.
When I started,
You sometimes you talk yourself out of something, or you, I can't remember exactly what happened. But I can see the idea of trying to work away from it a little bit sometimes. Well, that's the thing, I graded everything I had, so let's go back to my office, see if we can wade through the mess in there. Oh, yeah, so, if you want to, come to the office, I can print one out, or it's up on the website now. I don't have hard copies, I can give them all away, but it's up on the website. Latest update. That's the one, yeah. Good.
Kaya kabri yun, okay?
Well,
You're gonna need one right here too.
of course. I'm using all the plus and minus, and that's why you always go back.
Kaya pa ay kolos to.
4 to 16 over what?
Checking my solution.
Over x plus 3, x plus 8. Well, no, what you did, like subtracting this out. Right? So if you subtract that, what's left on
Oh,
this?
your mom helps you?
0. You can never like make an equation your way. You can't make it equal sign.
Sa iyo natin yung
There will be a 0 left here.
kaya ay
So let's see.